Hi there! This video is going to show you how to work out every single problem on the Equivalent Expressions Study Guide to help prepare you for the Equivalent Expressions test. Okay, so number 1 says, which expression is equivalent to -7 times w plus 5 times -2? Something you really got to know right here is this word equivalent, okay? So you want to know which expression equals this expression right there. And you see that we have parentheses right here around this -7. It's right there smushed next to that w. That means multiply. So it's really -7 times w, which is -7w, okay? And then right here, I have this 5 multiplied by this -2. It's a positive 5 times this -2, and a positive times a negative is a negative. So you get -10 or -10, okay? Something that could be greatly helpful when you take this assessment, if you ever have to multiply or divide, this thing might help you right here, this little tic-tac-toe chart, okay? And I'm going to remind you how to use it. So when you're multiplying, you use it going this way, using the rows. So a positive number multiplied by a negative number gives you a negative product. Product is the answer to a multiplication problem. A negative number written first multiplied by a positive number written second gives you a negative product, or a negative answer. And a negative number written first multiplied by a negative number written second gives you a positive answer, all right? So right here we had a positive times a negative, so positive times negative gives me a negative. That's how we got that -10, all right? Now I have a -7w and a -10, so let's make sure we have that matched here. Right here, this is a positive 10 minus 7w, that's a -10, so that's not it. -7w plus 52, nope, that's not even on there. So that leaves this as our solution, -10 right there, and a -7w right there, okay? So these can be written like this. All right, let's go ahead and take a look at number 2. Which expression is equivalent to -8y plus -3 times a -4? These mean multiply. Remember, when those parentheses are smushed like that, that means multiply, all right? So we're going to start out right here as -8 times y, which is -8y. And then I have this -3 times this -4, and a negative times a negative right there gives you a positive. So a -3 times a -4 is a positive 12, okay? And we can rewrite this as a positive 12 and a minus that 8y. All right, so let's go ahead and see which one matches up with that. -8y minus 12, nope, that doesn't match. Those aren't even the same numbers. So -8y plus 12, there we go, right there. Okay? Okay, number 3. Enter the value of p so that the expression -8 times the quantity of h minus 2 is equivalent to the quantity of h plus p times a -8. Okay, let's go ahead and set these expressions equal to each other, and let's get started. So write that as -8 times h minus 2. It's going to be equivalent to the quantity of h plus p times a -8. Okay, so here they're trying to trick you a little bit. This right here, this times -8, you can rewrite it in the front right there and just erase it right there. That right there is the same thing like that, okay? So if you want, if it's confusing to you, you can rewrite it. You have -8 times h plus p, all right? That's the same thing, because that means multiply, and when it's right there, it also means multiply. So now we got to figure out that value of p, okay? So let's go ahead and see what matches here. So I got these -8s are already equal to each other. Okay, those match up. What else do we got? Oh, that's a positive h, and that's a positive h. So those match. So all that's left is this positive p equaling -2. So p equals -2, or -2 equals p, same thing, okay? Number 4, let's try that one now. By the way, you should be pausing the video so you can be practicing it on your own. Don't forget that part, okay? I just showed you how to do this. You should pause the video and try this one on your own. Okay, enter the value of p so that this expression 5 times the quantity of -2 plus r is equivalent to the quantity of p plus r times 5. Okay, and again, you can rewrite it like we did over here. It doesn't matter, but for this one, I'm going to keep it like it is. So 5 times the quantity of -2 plus r is equivalent to the quantity of p plus r times 5. Okay, so let's go ahead and look at this here. So these both have to be equal. So the 5s are already equal. They're on the outside of those parentheses multiplied by that quantity. That's a positive r, that's a positive r. So those equal. So that's left, we got a positive p equaling negative 2. So negative 2 equals p, or p equals negative 2. Same thing, okay? Number 5. Enter the value of n so that the expression, the quantity of negative 2 times e minus 5 plus the quantity of 5e plus 10 is equivalent to the quantity of n plus 5. Okay, so we got some work to do here. So I'm just going to copy it down and set it up. Okay, make sure you copy it down correctly. Is equivalent to the quantity of n plus 5. Okay, copy down correctly. All right, look in front of these, or look inside the parentheses. See how nothing can be simplified there? They're not like terms. Look in front of the parentheses. There's no number, there's no symbol, so we can drop those parentheses. Okay, right here, you cannot go 5e plus 10. Those are not like terms. So look in front of it. Oh, we have a symbol there. So let's use the distributive property. Positive times 5e is a positive 5e. Now a positive times a positive 10 is a positive 10. And that's going to be equal to, let's look at this. Can you go n plus 5? Nope, they're not like terms. Now look in front of the parentheses. Do you see a number or a symbol? Nope. So go ahead and drop those parentheses. Okay, now it should look like this. Now it's just a matter of just combining your like terms on the same side of the equal sign. So I got a negative 12e plus 5e. So think of it, you're 12 to the left of 0. Then you're going to go to the right 5 units. You're still in the negative section, but it puts you to negative 7e. And then I got a negative 5 plus 10, okay? Negative 5 to the left of 0, you're 5 to the left of 0. Then you go to the right 10 units. That puts you at a positive 5. And that's going to equal n plus 5, okay? So now let's go ahead and take a look at it. Let's see what is equivalent, because we want to enter the value of n so that this expression is equal to this expression. So let's see. There's positive 5 right there. Those match. There's a positive 5 right there. So that leaves that n is equal to negative 7e. All right, you should pause the video, try this one on your own. Enter the value of n so that the expression, the quantity of negative 7a minus 25 plus the quantity of negative 3 times a minus 50 is equivalent to the quantity of n minus 75. So I'm going to write it down. And please make sure you're copying it correctly, okay, when you rewrite it. Okay. All right, let's go ahead and look at these parentheses. Nothing you can combine in there. Nope, there's no like terms. Now look in the front. Is there a number or symbol? Nothing, so you are allowed to drop those parentheses. 7a minus 25. Okay, right here, nothing to combine. They're not like terms, but look in front. Oh, look, you got a symbol. Remember, if you have a number or a symbol, you got to use that distributive property. So a positive times a negative 3a. Oh, remember? Positive times a negative gives you a negative. So positive times a negative is a negative 3a. A positive times a negative 50 is a negative 50. And that's going to equal, oh, look, there's nothing in front of those parentheses, no number or symbol, so we can drop those parentheses. And also, there's no like terms, so yeah, drop those parentheses. Okay, let's see. Oh, we got to simplify it. We got some like terms to combine right here. Negative 7a minus 3a. So think of this. You're to the left of 0, you're at negative 7, okay? Then you're going to go further left 3 more units. So you're at negative 7, go 3 more units to the left, and that puts you at negative 10a, okay? That's what those combine to. Okay, now you're at negative 25 minus 50. Those are like terms. So you're at 25 to the left of 0. You're going to move 50 more to the left of 0, and that puts you at negative 75. And that's going to equal n minus 75, because that's what we have. Okay, let's go ahead and let's figure out that value of n. Okay, let's see what matches here. So we're at negative 75 here, or minus 75. Okay, those match. Those are equivalent. So that leaves that n is equal to negative 10a. Number 7. Enter the value of P so that the expression negative 30 plus 33G is equivalent to P times the quantity of negative 10 plus 11G. Okay, so let's go ahead and let's set these equal to each other because we got it. It says equivalent right there. So we got negative 30 plus 33G is equivalent to P times the quantity of negative 10 plus 11G. Okay? All right. So what we're going to do right here, we have to factor this, okay? To be honest with you, this is what we got to do. We got to get the value of P right there, okay? And I got to make it to where both of those are equal to each other. So this is what we're going to do, okay? We're going to factor out a 3. And when we factor out a 3, I want this expression to equal this side right here, okay? So 3 multiplied by what number gives you negative 30? It's negative 10. Double check. 3 times negative 10 gives you negative 30, okay? Now 3 multiplied by what number gives you a positive 33G? 3 times a positive 11G gives you 33G. Okay, now let's go ahead and double check that. Make sure you understand that, okay? So I'm going to go ahead and show you using the distributive property. 3 times negative 10 is negative 30. 3 times a positive 11G is a positive 33G. See how this expression is equal to this expression? Okay? They're interchangeable. They're equal to each other. Now this is called factoring because I factored out a 3 and you use the distributive property to double check that they're equivalent. Okay? Now that we've done that, now it'll be easier to see what the value of P is. Because look, since you want to know what P is, and we set them both equal to each other, now you can see how they're equal. So look, right here, positive 11G matches this positive 11G, okay? Then you got this negative 10 right here. That's equal to this negative 10 right here. So all that's left is P equaling 3, or 3 equaling P. Okay? I know that one was weird, but try the next one on your own. It's very similar to 7, okay? Try it. Pause that video. All right, enter the value of P so that the expression 6 plus 10 times N is equivalent to P times the quantity of 2 plus 3 and 5/10 N. Okay, let's set that up. I'm going to copy it down again. Remember, equivalent means equal. Okay. Now see how the P's already out here by itself? We got to set it up so we can have a number that we factor out. So think of a number that would go into 6 and 10 and 5/10. Okay? And I'm going to tell you it's 3. Okay? So 3 times what number gives you 6? It's 2. 3 times what number gives you 10 and 5/10? A positive 10 and 5/10? It's a positive 3 and 5/10. But since it's 3 and 5 or 10 and 5/10 N, you need to do 3 and 5/10 N. Okay? And that equals P times the quantity of 2 plus 3 and 5/10 N. All right? So let's go ahead and find that value of P. Okay, you know how they're equal to each other, so let's go ahead and start seeing exactly what's equal. Those 2's are both positive. This is a positive 3 and 5/10 N. This is a positive 3 and 5/10 N. Okay, so that leaves us that P is equal to 3, or 3 is equal to P. Same thing. Okay, those ones I think were probably pretty darn tricky. So what you need to do, honestly, to do this, to be successful, cover up those answers and see if you can do it again. If you get stuck, take a peek, okay? See what we did before. I want you to revisit those problems at the end of this video. Try it again, okay? All right, number 9. Select all expressions that are equivalent to C plus 1 and 5/10 times C plus 4 minus 1 and 5/10 times C minus 1. So this is really a matter of just combining your like terms. So remember, there's just a 1C sitting there, right? So if it helps, you can put a 1 in front of it. There's only 1C chilling right there. Okay, so 1C plus 1 and 5/10 C is 2 and 5/10 C. Minus 1 and 5/10 C, that just leaves 1C. Or if you're somebody that recognizes additive inverses, right there, those are additive inverses. You know, they're opposites. A positive 1 in 5/10c minus 1 in 5/10c, that's 0. So that's, you know, that's 0. That's gone. So now you're left with 1c or c, same thing. And then you got 4 minus 1. 4 minus 1 is a positive 3. Okay, so you can write it like that, or you can write it like 3 plus 1c, like they're smushed together, okay? Or you can write c plus 3, or 3 plus c. Those are all equal to it, all right? They're all equivalent. They're all interchangeable. Okay, I don't like what that looks like. There, okay. So now let's go ahead and see, because it says select all expressions that are equivalent to that. So we got 3 plus c. Yep, we got that one. C plus 5. Heck no, that's not even one of the numbers on there. Let's go ahead and simplify this. 2 in 5/10c minus 1 in 5/10c. Well, 2.5 minus 1.5 is 1. So it's really 1c plus 3. Yep. And then right here I have 1c plus 3. So those are your 3 solutions to this problem. Okay? Okay, number 10. Select all expressions that are equivalent to 4f plus 6f. I'm just combining my like terms real quick. Plus 16 minus 6f minus 4. Okay, so check those right there. Those are the like terms right there. I got a positive 6f minus 6f. Those are additive inverses. You know, they're opposites. They're 0 pairs. So when you add them together, that ends up to be 0. So we're left with 4f, and then we got 16 minus 4. 16 take away 4 is positive 12. Okay? So another way you can also write this is 12 plus 4f, like that. All right, so let's go up here and check and see which numbers or which expressions match these expressions right there. So 4f plus 10, nope, that's not even the same numbers. 4f plus 12, yep, that's correct. And let's go ahead and simplify this. 10f minus 6f, well, that's 4f plus 12. Yep, that one matches. Okay, let's simplify this one. 10f minus 6f is 4f plus 10 though, so that one's not going to match. So those are your 2 solutions right there. All right, number 11 says enter the value of n, so the expression, the quantity of 12 times z minus 36 plus the quantity of z plus 12 is equivalent to the quantity of n times z minus 24. All right, so I'm going to go ahead and rewrite all these expressions and set these expressions equal to this expression, okay? And try to leave yourself some room. Something that I always do is when I write my z's, they kind of look like 2's. So I'm going to try my hardest to make sure that you can tell that a z is a z with my handwriting. Okay, so you're going to go ahead and look at this first expression right here, and you'll see that those are not like terms, so you can't combine them. And you're going to look in front of the parentheses. There's no number or symbol there, so we can go ahead and drop those parentheses. 12z minus 36, okay? And then this right here, this expression, z plus 12, those are not like terms, so you cannot combine them, but you do have a symbol in front of these parentheses, so go ahead and go a positive times a positive z, it's a positive z, and a positive times a positive 12 gives you a positive 12, okay? Now look at the other side of that equal sign. You'll see here that there's no number or symbol in front of those parentheses, so we can go ahead and drop those parentheses. At n times z minus 24. All right? Okay, now on that left-hand side, let's go ahead and combine the like terms. So I have this 12z plus z. 12z plus another z gives you 13 z's. 13z. And then I have a negative 36 plus 12. All right, so you think of this. You're 36 units to the left of 0. Okay, you're like way over here to left, and then you got to go to the right, because it's positive, right 12 units. Okay? That's still putting you in the negative section on the number line, but you're only at negative 24 now. Okay? And that's going to be equal to n times z minus 24. Okay, remember we're looking for the value of n. Okay? So let's go ahead from here. Let's see what we have that's already equivalent. We got this minus 24 here, you know, the negative 24 right there. We got the minus 24 right there. And so what we need to do, oh, we see that the n is attached to the z and the 13 is attached to the z, but we're looking for n. So these are both multiplied by that coefficient there. So since these z's are equal to each other, then n is equal to 13. Or 13 is equal to n, same thing. Okay, see what happened there? All right, you should pause the video, try number 12 on your own, okay? Enter the value of n so that the expression the quantity of 12k plus 13 plus the quantity of 5k minus 8 is equivalent to the quantity of nk plus 5. All right, so I'm going to go ahead and rewrite everything down here just so I can set it equal to each other. All right, so right here, 12k plus 13, those are not like terms. Look in front of it. There's no number or symbol there, so we are allowed to drop the parentheses. Okay, right here, 5k minus 8, those are not like terms, but look in front of it. Remember, if you ever see a number or a symbol in front of parentheses, use the distributive property. Right here we have the symbol, the positive symbol. So positive times a positive 5k is a positive 5k. A positive times a negative 8, or minus 8, positive times a negative gives you a negative. Okay, so minus 8 right there. And that's going to equal, well, those aren't like terms, so look in front of it. There's no number or a symbol, so you drop those parentheses. Okay. Well, there's a lot we can clean up, I think, right here. We've got this positive 12k plus 5k. 12k plus 5k, that's 17k. Okay. And we got positive 13, so you're 13 units to the right of 0. Minus 8, so 13 units to the right of 0, you're going to go to the left 8 units, and that gives you a positive 5, and that's going to equal n times k plus 5. All right, I'm going to use the colors because I think they help. What's matching here? Oh, I got a positive 5 right here, positive 5 right here. Look, those k's are matching right there. They're both positive. They're multiplied by that coefficient right there. So since we were looking for n, the n's right there, so the n would equal to 17. But just to show you that, see these k's are equal to each other right there? So n is equal to 17, or 17 is equal to n, same thing. Okay, number 13. Enter the value of n so that the expression, the quantity of 11 times j plus 12 plus the quantity of 12 minus 3j is equal to the quantity of n times j plus 24. So I'm going to rewrite it so I can set it equal to each other. That's an 11j, okay? Okay, so right here, you cannot combine those. They're not like terms. Look in front of it. There's no number or symbol, so we don't have any distributive property to do. We are allowed to drop the parentheses. 11j plus 12. Okay, 12 minus 3j, nope, not like terms, but you got the symbol in front of it, so positive times a positive 12 is positive 12. Positive times a negative 3j is a negative 3 times j, and that equals, oh, let's see, those are not like terms. There's no number or symbol in front of the parentheses, so drop the parentheses. Okay, we can simplify it here. You got 11j's minus 3j's, 11, 10, 9, 8, that's 8j's. Well, we can combine these right here, 12 plus 12, that's a positive 24, and that equals n times j plus 24. Okay, we're looking for n, so let's try to single that out. We got the 24s that are already equivalent, they're both positives. We're looking for n, so, well, this j matches with this j right there, so n is equal to 8, or 8 is equal to n, same thing. Pause the video, try number 14. It's similar to number 13. Enter the value of n so that the expression, the quantity of 6 minus 9 times b plus the quantity of negative b plus 12 is equal to the quantity of n times b plus 18. So let's set them equal to each other. Okay. So those aren't like terms. Look in front of it. No number or symbol, so we can drop those parentheses. Okay, right here. Yeah, not like terms again, but you got a symbol in front of there. Positive times a negative b is a negative b. Positive times a positive 12 is positive 12. Equals. Okay, not like terms inside there, but you got no number, no symbol in front of it, so drop the parentheses. So n b plus 18. All right, let's see what we can simplify here. We got 6 plus 12. 6 plus 12 is 18. And then we got a negative 9b minus b. Okay, negative 9, so you're at negative 9, you're 9 units to the left of 0. And then you're minus 1, so negative 9 minus 1 puts you at negative 10. Remember there's a 1 in front of there. So it's negative 10b equals n times b plus 18. Okay, and we're looking for n, okay? So let's see what we can match up here. That's a positive 18. That's a positive 18. We're looking for n. Oh, and look, these b's match right there. Okay, and now look, n is equal to negative 10, or negative 10 equals n, same thing. Okay, see where we got that negative right there? All right, number 15. Enter the value b when the expression 15 times y plus b is equivalent to 5 times the quantity of 3 times y minus 2. So let's set them equal to each other. Okay, let's see. So we're looking for b right here, and these aren't in the same format. You see how this is all like factored right now and this one's not? So let's go ahead and use the distributive property here. We want it to look in the same format. So 5 times 3y is 15y. 5 times this negative 2 or minus 2 is a negative 10 or minus 10 equals 15y plus b. Okay? So now they look like they're in the same format, and we can go ahead and see what's matching here. Remember, we're looking for b, but these 15y's, they're both positive. They match. So we are left with the positive b is equal to negative 10. B equals negative 10. Okay? All right, number 16. You should pause the video, try it, similar to 15. Enter the value b when the expression 45 times k plus b is equivalent to 9 times the quantity of 5k minus 3. Okay, so they're not in similar format. This one's factored, this one's not, so let's go ahead and distribute. I got that number in front of it. 9 times 5k is 45k. 9 times a negative 3 is negative 27. Okay, now let's go ahead and find b. All right, let's see what matches here. So we got these 45 times k's that are equal to each other. Got a positive b equals negative 27. Okay, you want that variable to be positive, so that's what we got there. Number 17 says Sophia is shown two expressions, 2 times the quantity of 4x plus 3 and 12x plus 10. Sophia claims that the expressions are equivalent because when x equals 1, both expressions are equal to 22. To show that Sophia's claim is false, evaluate each expression when x is equal to 5. So they're telling you right now that she's wrong, because when you put this 1 right there and you substitute this 1 right there, when you do it all out, they're both not going to equal 22. Okay, so they're saying she's wrong. So to prove she's wrong, you have to do this right here. Probably the most important thing to notice about this is you need to enter your answer to this first part in the first box and enter this answer right here in the second box. If you put them both in the same box, it's going to mark it wrong, even if technically you're right, okay? If you switch them around, put this one in the first one, this one in the second one, it's going to mark it wrong, even if technically you're right, okay? So make sure you're really following directions. Okay, so we're supposed to enter that value when the value of 2 times the quantity of 4x plus 3 when x is equal to 5. So we're going to use substitution to prove this. So you're going to go ahead and substitute that value in for x. So you're going to replace that x with the 5, okay? So it's really going to be 2 times the quantity of 4 times 5 plus 3, okay? So we got to do this part right here first. 4 times the 5 is 20. We're going to add 3 to that. Okay, so see what happened here? That 5 went in for right there, so that's why it came right there. I could have also done parentheses. That means the same thing. 4 times 5 is 20, and then 20 plus 3, that's 23. And we're multiplying it by 2. 23 times 2 is equal to 46. Okay, so again, that goes in the first response box. So here's my first response box. Put that 46 right there, okay? Okay, enter the value of 12x plus 10 when x is equal to 5. Enter your response in the second response box. Okay, so we're going to substitute again. We're going to put that 5 in for the x right there. I'm going to do it off to the side. So it's really 12 times 5 plus 10. Well, 12 times 5 is 60. 60 plus 10, that equals 70. Okay? So that's why this Sophia girl is not right. Because when you substitute values in for x, you're supposed to get the same answer for each expression. Since you don't, that means she's wrong. Those expressions are not equal to each other. Okay? All right, let's look at number 18. Tobias is shown two expressions, 6 times the quantity of 3x minus 1 and 16x minus 2. Tobias claims that the expressions are equivalent. He says that this is equal to this because when he did x equals 2, when he plugged it in, he says that both of them are equal to 30. But he's wrong because he's false. It's saying that he's wrong. So what you're going to do to prove he's wrong is you're going to evaluate each expression when x is equal to 4. So you're going to take a 4 and put it in for x, and take a 4 and put it in for x, and show that they're not equal. If Tobias was right, then when you put in that 2, both of them would equal 30. But nope, that's not the case. He's wrong. We got to prove it. Okay? So enter your value of 6 times the quantity of 3x minus 1 when x is equal to 4. So again, you're going to substitute, put that right there. So I'm going to just rewrite it. So 6 times the quantity of 3 times, put that 4 in right there. Okay, if you want to, you can put the parentheses if you like. Minus 1, like that. See how it matches? Instead of the x, we put the 4 in. Okay, now we got to do right here first. 3 times 4 is 12. And then we got to subtract 1, and that's going to be times 6. 12 minus 1 is 11, so it's really 6 times 11. 6 times 11 is 66. And again, put that in the first response box. Okay? So that goes right here. All right, the next expression says enter the value of 16x minus 2 when x is equal to 4 in your response in the second response box. Okay, so again, we're going to substitute. That's called substitution. You're substituting it, like when you have a substitute teacher. You have someone else standing in for the teacher, so put that in for x. So you got 16 times 4. And you could have done the dot right there if you like that way to represent multiplication, but I always prefer the parentheses. And then subtract 2. 16 times 4, that is 64. Then you're going to subtract 2, and that is equal to 62. Okay? 64 subtract 2 is 62. And you'll see that's why Tobias is incorrect, because they're not equal to each other. The expressions are not. Okay? All right, number 19. Manuel claims that the expression negative 7 times the quantity of m plus 3 is equivalent to negative 7m plus 21. Which statement identifies and corrects the error in Manuel's work? So they're basically saying within the statement that Manuel messed up. They're saying and acknowledging, yeah, he made an error. We have to identify the error. So instead of going through A through D and reading that to get confused, I want you to go ahead and do it the right way, okay? Then we can identify where Manuel messed up. So let's go ahead and let's draw it down here. Make sure you copy down correctly. So it's negative 7 times the quantity of m plus 3. And we want to be equivalent to negative 7m plus 21. So right now they're in different formats. This one's factored, this one's not. So go ahead and let's use the distributive property to unfactor this. So negative 7 times m is negative 7m. Negative 7 times a positive 3 is a negative 21. Remember, a negative times a positive gives you a negative, okay? So negative 7m plus 21. So what are you seeing here? Are these equal to each other? They are not equal to each other, all right? See how this right here matches? So where do you think Manuel probably messed up? I'm thinking he probably messed up when he was multiplying right here, all right? So if he thought that these were going to be equal, the only difference is this one's a positive 21 and this is a negative 21. So I'm assuming that the mistake was when he was using the distributive property. He must have forgot that negative 7 times a positive 3 is a negative 21. So since the error was probably when he was multiplying, let's go through the problems right here and see which one acknowledges that error, okay? So Manuel did not add 3 from the negative 7m. The equivalent expression is negative 4m. No, it's not. There's no negative 4m on there. Okay, so that's not the possibility. Manuel did not add 3 from negative 7. You're not adding, you multiply, so that's not it. Manuel did not find the product of negative 7 and 3. The equivalent expression is negative 7m minus 21. right there. Okay, so this is probably the answer. But let's check the D. Manuel did not keep the parentheses around 3. The equivalent expression is negative 7m times 3. Nope, that's incorrect. Okay, so that's why. Number 20 says Janie claims that the expression negative 8 times the quantity of h minus 5 is equivalent to negative 32h. Which statement identifies and corrects the error in Janie's work? Okay, so we acknowledge that she's made an error somewhere because she's saying that this is equal to this, but it's not equal to it. So let's go ahead and we're going to do it the right way before even reading this, okay? Because I feel like sometimes when you read this, it kind of confuses you. I don't know, it confuses me sometimes. So that's why let's try it this way. If you don't get confused easily, then maybe you can tackle it. Okay, let's go ahead and copy it correctly. So it's negative 8 times the quantity of h minus 5. Make sure you copy it down correctly, okay, and is equivalent to negative 32h, okay? All right, let's go ahead and do it the right way. They're in different formats. This one's factored, this one's not. So let's go ahead and multiply using the distributive property. Negative 8 times 8 is negative 8. Negative 8 times h is negative 8h. Negative 8 times a negative 5 is a positive 40. And Janie is saying that that is equal, okay? And they're obviously not equal, okay? Those aren't like terms and you can't. They're not equal. So that's why we put that symbol there. All right. So Janie is saying that this equals this. What could she have possibly done to think that this would equal this? Let's check. Looks like she must have added this or something. Janie did not subtract 5 from negative 8h. Well, we're not even subtracting here. We're supposed to be multiplying, so that's not it. Janie did not subtract 5. We're not subtracting because we have to distribute. Janie did not find the product. Okay, product is the answer to a multiplication problem, so that might be something here. We did have to do that. Janie did not find the product of negative 8 and negative 5. Do you have to multiply negative 8 times negative 5? Yeah. So the equivalent expression is this. Negative 8. That looks good. But then let's double check this. Janie combined all terms by adding negative 8h and 40. The equivalent expression is negative 8h plus 40. Okay, now that right there is tricky. Okay. So it looks to me like what Janie tried to do, she tried to combine these even though they're not like terms, okay? So I would say that the answer is D. Because it says she combined all terms by adding that even though it's not. So she should have gotten this, okay?